In order to talking about frequency distribution, let's look at an example called Houston Auto Repair. The manager of Houston Auto would like to gain a better understanding of the cost of parts used in the engine tune-up performed in the shop. She examined 50 customer invoices for tune-ups. The cost of the parts rounded to the nearest dollar are listed on the next slide. So we've already seen this data set before in our first chapter, so you should be familiar with those data. So the data set are called raw data. So the three steps necessary to define the classes for the frequency distribution with the quantitative data are, so remember, we also use frequency distribution to describe categorical data. Unfortunately, in this case, quantitative data, we need to define the category or classes first. So that will be related to how should we define the classes. So that is the three steps, which is necessary to define the classes. So first, determine the number of the non-overlapping classes. So for instance, you want to have 3 non-overlapping classes, 4 or 6. And the second, determine the width of each class. The third, determine the class limit, which means for each class, what is the lowest bound, what is upper boundary, what is the lower boundary. So the guideline for determining the number of the classes. So can you randomly pick up number? I need 5 classes, 3 classes. Generally speaking, you can, but we should also have some guidelines. So we usually use between 5 and 10 classes. So no smaller than 5 and no larger than 20 classes. Smaller than 5 is 2 small classes. Larger than 20 is too much classes. And a data set with a large number of the elements usually require a larger number of the classes. So if you have a large number, so you probably require a large number of the classes. And a smaller data set usually require fewer classes. Generally speaking, the goal is to use enough classes to show the variation in the data, but not so many classes that some contain only a few data items. So for instance, if you have 100 observation and you have 90 classes, so that kind of definition is useless. So how can you decide the width of each class? So use the classes of equal width. So that is one characteristic for each for the classes. So the width should be equal. Approximately the class width equal to the largest data value minus the smallest data value divide the number of the classes. So you can find the largest data value and you can find smallest data value. So if you try to remember in the first chapter, I remind you that every time you have the raw data, try to make it like data array, order it from the smallest to the largest or from the largest to the smallest, then divide by the number of the classes. So which means, or which is you decided before about the number of the classes. So making the classes the same width reduces the chance of the inappropriate interpretation. So there is one more note on number of the classes and the class width. So in practice, the number of the classes and the appropriate class width are determined by the trial and error. So that's what I said before. Generally speaking, there is no rule, but it's better to have some guidance than the rule. Once a possible number of the classes is chosen, the appropriate class width is found, because the largest and the smallest number is decided by the sample before you make the classes. And you pick up the number of classes, so naturally the width is found once you decide the number of classes. The process can be repeated for a different number of the classes. Ultimately, the analysis uses a judgment to determine the combination of the number of classes and class width, and that provides the best frequency distribution for summarizing the data. So you should know no matter what kind of experiment you did, you should make sure this kind of tabular way to describe the data can be efficiently deliver the information. How can you find the class limit? In order to find class limit, you must be chosen so that each data item belongs to one and only one class. The lower class limit identifies the smallest possible data value assigned to the class. The upper class limit identifies the largest possible data value assigned to that class. So each class have two class limits: lower class limit, upper class limit. The proper values for the class limit depend on the level of the accuracy of the data. An open-end class requires only a lower class limit or an upper class limit. So which means it can be from the largest number to positive infinite and smallest number to the smallest infinite. So the next concept is about the class midpoint. What is that? In some cases, we want to know the midpoint of the classes in the frequency distribution for quantitative data, because the class midpoint is the value halfway between the lower and upper class limit. So now let's go back to our example. Hudson Auto Repair. So if you choose 6 classes, so what will be the class wise? So if we look at the original data, we know the largest number is 109 minus 52, and so we got the range of the data set, and divide by the 6, which is the number of classes that we've already chosen, and we got 9.5, and we rounded the number to 10. So the class width is 10. So now we can do separate the classes. So the smallest number is 50, and from 50 plus 10, and we got 60. So the 10 we might not get it. So we are define 50 to 59, which doesn't include the 60 as our first class. 60 to 69 is our second class. 70 to 79 is our third class. 80 to 89 is our fourth class. 90 to 99 is fifth class, and this is our last. So then we will go back to look at the original data to see how many parts it caused between 50 to 59. So we know we only have the 2 parts. So that is the frequency distribution for quantitative data. Obviously, this take more works because we need first to define the classes, then count the frequency.